Hello, LFR2. Welcome. Today we're going to talk about LFR2. I can determine and interpret the intercepts of a linear relation. So let's go ahead and we are going to get started. Go ahead and follow along in the notes, and here we go. So let's take a look at this thing. It says miners are exploring 90 feet underground. The miners ascend in an elevator at a constant rate over a period of 3 minutes until they have reached the surface. In the coordinate grid, the horizontal axis, remember, horizontal, this way. The horizontal axis represents the time in minutes from when the miners start ascending, and the vertical axis represents the miner's elevation relative to the surface in feet. So let's just take a look at all that. There's a lot to think about there, right? Miners, they're exploring 90 feet underground. So at the initial time, or time zero, when no minutes have elapsed, they are 90 feet underground. So here on this axis, no time has elapsed, and they're 90 feet underground. What point represents the miner's elevation at the beginning of beginning of the ascent? So that would be 0 minutes, negative 90 feet. Now they're going to raise at a constant rate over 3 minutes until they reach the surface. So at the surface, at 3 minutes, they are not below the surface, not above the surface, they're at the surface. That's 0. So at 3 minutes, they have reached the surface. What point represents the miner's elevation at the end of the ascent? 3 minutes, 0 feet. Plot this point. Part C says connect with a line segment. Oh, let's see what I can do today. That's not too bad. We'll go with it. Okay. What is the point where the graph crossed the y-axis? Well, it's 0, negative 90. And it crosses the x-axis at 3, 0. Interesting. Those are the 2 points that we just found, right? The intercept, where it intercepts the axis, okay? The point where the graph intersects the y-axis represents the beginning of the miner's ascent. Will the point where the graph intersects the y-axis always be the lowest point on a linear graph? Why don't you take a minute and think about that? Go ahead and hit pause and give an answer. Hopefully you hit pause. Okay, so will it always be the lowest point on a linear graph? I'm going to say no. And I'm going to give an example as to why. What if you were on a mountain? What if you're on a mountain and we're coming down the mountain? What if you started here on the mountain and then you came back to the surface? That would be a point where it would be maybe the highest point in a linear relation. So no, it will not always be the lowest point on a linear graph. Okay, enough said with that. Let's go ahead and get into the meat of what we're trying to do today. So we got these two things, what we just talked about also. It says the graph in the Explorer intersected the axes at 0, negative 90, and 3, 0. The y-intercept, notice how that's got that. It's got that, shaded part. Yeah, we're gonna make sure we're gonna know this one. The y-intercept of a graph is the y-coordinate of the point where the graph intersects the y-axis. Right, we got our x, we got our y. Our y-intercept is where it intersects. Oh, wow, I just did that one goofy. We got our y-axis there, right? So the x-coordinate along this axis, it's not moving left and right or x. It's not moving left or right. So not moving left or right, right on that y-axis, that means x is 0. So if you're trying to find a y-intercept, the x-coordinate is always 0. If you're trying to find a y-intercept, the x-coordinate is always 0. Conversely, if you're trying to find an x-intercept on this axis right here, it's not up and down, it's only x. There's 0 up and down and y. The x-intercept of a graph is the x-coordinate of the point where the graph intersects the x-axis. The y-coordinate of this point is always 0. That's the big thing. That's kind of like the big point of this whole thing that we're trying to do right now. This is the determining part. talk about the interpreting later. Find the x and y intercepts. Basically, here's your steps. To find the x-intercept, replace y with 0 and solve for x. Then you can start again, go back to the original equation. To find the y-intercept, replace x with 0 and solve for y. So let's do that. Our equation here is 3x minus 2y equals 6. If I'm trying to find the x-intercept, I plug 0 in for y. So anywhere I see y up here, I'm going to replace with 0. 3 minus 2 times 0 equals 6. 3x equals 6. Divide both sides by 3. And x equals 2. The x-intercept is 2. Okay, that's good. That's the x-intercept. The y-intercept. To find the y-intercept, we start again with the same first equation. We replace x with 0 and solve for y. Well, if I replace x with 0, 3 times 0 is still 0, right? 0 minus 2y, or negative 2y equals 6. Divide both sides by negative 2. And y equals negative 3. I'm not saying it's easy. I'm saying if you follow these steps, it's going to work for you every time. Let's look at part B. Here we go. It says negative 5x plus 6y equals 60. To find the x-intercept, we replace y with 0 and solve for x. So anywhere I see y in this equation, I'm going to replace that with 0. Well, 6 times 0 is 0. That goes away. I used to have negative 5x equals 60. Divide both sides by negative 5. And x equals, well, a positive divided by a negative is a negative. And 60 divided by 5 is 12. The x-intercept is negative 12. If you wanted to write that in a coordinate point, x is negative 12, y is 0. You could write it like this, negative 12, comma, 0. To find the y-intercept, replace x with 0 and solve for y. If you're trying to find the y-intercept, you kind of got to have y left over, right? So anywhere I see x in this original equation, I'm going to replace that with 0. Negative 5 times 0, that's 0, it's gone. 6y equals 60. Divide both sides by 6, y equals 10. So the y-intercept is 10. The y-intercept is 10. When x was 0, y was 10. Another way to think about that, all right? If 5 comma 0 is on a graph, is 5 comma 0 the y-intercept of the graph? Explain. Take a minute, pause. Again, I hope you're pausing. All right, so let's take a look at this. If 5 comma 0 is on a graph, is that the y-intercept? I'm going to show this in two different ways. One, the y-intercept is when x is 0. X is not 0 here. We know this is no. This would be the x-intercept because that is when y is 0. No, this is the x-intercept. And here, if you're not sure, do it graphically. Just sketch a little graph. Just sketch a little graph, right? This is x, this is y. I go 5 in x, 0 in y. I'm right there on that axis. That is the x-axis. That is the x-intercept. Okay, your job, again, 2 steps. To find the x-intercept, set y equal to 0, solve for x. To find the y-intercept, set x equal to 0, solve for y. Push pause, try these out, and then come back. So awkward every time. Hopefully you paused and did them, so I'm going to do them right now. Find the x and y intercept. So the x-intercept, I need to set y equal to 0, solve for x. If I do that, set y equal to 0, this becomes 8x plus 7 times 0 equals 28. This just disappears to 0. So this is 8x equals 28. Divide both sides by 8. So right now I've got x equals, ooh, did this too big, didn't I? X equals 28 over 8. I can simplify that. I can divide both top and bottom by 4. And I get 7 halves. Notice how I didn't take that and make that a mixed number or a decimal. 7 halves. To find the y-intercept, I have to do this a little smaller here. To find the y-intercept, set x equal to 0, solve for y. Set x equal to 0 and solve for y. So I would have 8 times 0 plus 7y equals 28. 8 times 0 is just 0. I'd have 7y equals 28. Divide both sides by 7, and y equals 4. So your x-intercept is 7 halves. Your y-intercept is 4. If you wanted to rewrite these, this could be 7 halves, comma 0. And this could be 0. Try that again. 0, comma 4. You could also write that. Ooh, undo that. 0, comma 4. Let's look at number 4 here. Doing the same thing. I'm going to show you another way, a way that helps me think about things. And if you don't like it, go back and do the first way, okay? I'm going to make a little table here with x and y. I know for the x-intercept, the x-int, the x-intercept, I know that y is 0. I need to find x. For the y-intercept, I know that x is 0, and I need to find y. So here's what I'm going to do. I'm going to take, for this x-intercept, I'm going to find that first. I'm going to set y equal to 0. This just disappears, right? This is negative 6x minus 0. So negative 6x minus 0, don't even have to write it, equals 24. Divide both sides by negative 6. X equals negative 4. Negative 4. For the y-intercept, we start all over. And instead of replacing y with 0, we're going to replace x with 0. So in this case, this is 0. 0 minus 8y, or negative 8y, equals 24. Divide both sides by negative 8. This simplifies to 1. That's why this works. It's just 1y. 24 divided by negative 8, y equals negative 3. So negative 4 is 0, 0, negative 3. Those are my two intercepts. I've just shown you two different ways to work. Do whichever one you like best. They both get the same things. You both do the same things on that. So, all right, let's go ahead and move on to the next page here. Ooh, interpreting. I take that back. I'm going to skip to the next page, the explain 3. We're going to graph these things. We'll do the interpreting in the part 2 of the video. Graphing linear equations using intercepts. In other words, taking the points, the intercepts that we just found, and now running a graph through them. Okay, let's go ahead and do that. You can use the x and y intercepts to graph a linear equation. That's absolutely true, because all you need is 2 points to define a line or a line segment. Again, we'll talk about that. It says use intercepts to graph the line described by each equation. I have half y equals 3 minus 3/4 x. Fractions, but it's okay. We can do this part, okay? Find the intercepts. In other words, to find the x-intercept, same thing. Oh, I see what they did. See, they wrote this in standard form. In other words, standard form is just bringing all the variables to one side and the number to the other side of the equal sign. When I say sides, I mean an equal sign. So that's how they did this. You don't have to. You can keep it in this way. In fact, I'll show you an example of how to just keep it like that and still get the same answer. So if I find the x-intercept, this is when I set y equal to 0 and solve for x. I have 3/4 x equals 3. I multiply both sides. If you remember, I invert, or I flip the fraction and multiply. So multiply both sides by 4/3. I simplify. This simplifies to 1, just 1x. This simplifies to 1 times 4, which is 4, divided by 1 times 1, which is 1. X equals 4. Okay, that's great. That's great. To find the y-intercept, I set x equal to 0. That's gone. I have half y equals 3. I would, when you're thinking about this, like I got to divide by half. But when you divide by a fraction, again, you flip that fraction and multiply. So multiply both sides by 2 over 1. 2 over 1? It sounds an awful lot like just 2. Multiply both sides by 2. So if you do that, 2 times half is just 1. 1y equals 3 times 2, which is 6. So let's graph these 2 points, right? We need to graph the line by plotting the points 4, 0, because when x is 4, y is 0. 4, 0. These go by 2. Be careful. And 0, 6. Okay? Now, one of the most common mistakes that I see, do not do this, is people will go, oh, 4, 6, and put a point up there, and they just have 1 point. No, you've got 2 separate points. You got 2 separate intercepts. This is when y was 0, so 4, 0. This is when x was 0, 0, 6. Draw the line. Oh, try it again today. Oh, I missed. Pretend like that didn't happen. There we go. Draw the line through and put arrows at the end, because as far as you know, that line goes on forever. I haven't told you otherwise, so just assume that it does for now. Okay. So let's look at part B. It says 18y, get that a little bigger in here, 18y equals 12x plus 108. So you could do standard form, and let's go ahead. We can take a minute and think about this. Standard form just means the variables x and y are on one side of the equal sign and the numbers on the other. I don't want to do it like that. I'm going to do it straight from here. 18y equals 12x plus 108. Okay. To find the x-intercept, we're going to set y equal to 0. Again, to find the x-intercept, we're going to set y equal to 0 and solve for x. This gives us 0 equals 12x plus 108. Hey, it's a two-step equation. We can do this. It's a two-step equation, right? So I subtract 108 from both sides. That's what I'm going to do. You can subtract 12x. You're going to get the same thing. Subtract 108 from both sides. Whoa, 108. And on the left, you get negative 108 equals 12x. We still need to get x by itself, right? Divide both sides by 12. And negative 108 divided by 12, a negative divided by a positive is a negative. And 108 divided by 12, I'm sorry, let me try that one more time. A negative divided by a positive is a negative. When they're opposite signs, it's a negative. A negative, I'm sorry, 108 divided by 12 is 9. So we got negative 9 is x. There we go. So when x is negative 9, y is 0. Negative 9, 0. If you want to do the y-intercept, throw a different color on here for us. Y-intercept. Oh, watch this. This is fun too. Make that pen a little bigger. do the y-intercept over here. I like that. Okay. I just can't screw up now. We're going to take this same equation and we're going to make x 0. So I have 18y. Oh yeah. Make that, bring that back down. There we go. So I've got 18y equals, well, 12 times x, but x is 0. So this is just gone, equals 108. Let's see here. If I divide both sides by 18, y equals 6. How did I come up with that so fast? 6 times 8 is 48. 6 times 10 is 60. You add those together, you get 108. There we go. So this is, again, this is when x equals 0. So x is 0, y is 6. I'm going to take and draw my line through these 2 points. And I have graphed it. Again, the 2 points, the x-intercept was -9, 0. The y-intercept was 0, 6. And we drew a line through them. Okay, that's going to be plenty of time for what we're looking to do here right now. So let's do this. You've got one your turn. So go ahead and hit pause, do your turn, and then come check your answer. I really hope you hit pause. Okay, so they kind of already graphed it for us. That's okay, we can still find the intercepts. We can check our answers. We know that this should be -6, 0. And let's see, 2, 4, 6, 8. Should be what? 0, -10. So let's do this. To find my x-intercept, I set my y equal to 0. So 0, so 3 times 0, right? That's where I get that. Equals -5x minus 30. I'm going to go ahead and add 30 to both sides. 30 equals -5x. Divide both sides by -5 to get x by itself. Positive divided by a negative is a negative. This is -6 is x. In other words, this x-intercept is -6, comma, 0. -6, comma, 0. Nailed it. Nailed it. See if we can get the y-axis or the y-intercept, right? The y-intercept again is when x equals 0. Y-intercept. So 3y equals -5 times 0, which is 0. 0 minus 30, so -30. Divide both sides by 3. Y equals -10. Again, this is when x was 0. Y was -10. 0, -10. Nailed it. Nailed it. Looks good. All right. The part 2 is going to give the interpreting part. So let's go ahead and take a look at what I want you guys to do here. For this part, I want you to at least do 1 and 2 on 215. Then go ahead and do 3, 5, and 7. We'll do the interpreting in the next part, but you'll eventually do those. For graphing, I'd like you to do 13 and 15. And also 17. So coming along with part 2, there'll be some more problems to work on. Either way, we're going to get back after this. Hope you guys have a great day. Talk to you soon.